Welcome back everyone, Patrick here. Moving on to another question, still dealing with algebraic tiles. So in this particular case, what we're given is the length and width of a rectangle. So notice we have 4 different rectangles we're dealing with. So we've got the length here, the width, etc., etc. And what we have to do is model the rectangle area using tiles. So this one's going to be fairly unique. So usually when we're finding the area of a rectangle, so if we have a rectangle, we have the length, we have the width, and we know the area is equal to length times width. Right? So for example, here if we have a rectangle that has a length of 3, a width of 2, we would just multiply those. The area would end up being 6. But now what we're going to do is model the area visually using tiles. So it's going to be a little bit unique, especially when we get to these different rectangles where we have a mixture of variables and numbers for the length and the width. And so before getting into that, what I want to do is quickly just review the different tiles that we were using before. Now, in previous videos, we were using solid shapes and then hollow shapes. Remember, the solid shapes were positives, the hollow shapes were negatives. Well, notice here, we're only going to be dealing with positives. So we're only going to be dealing with these solid shapes when we are modeling these areas. So just as a review, if we have a small square, like that, that represents +1. If we have a rectangle like that, that represents +x, and then this rectangle can also be horizontal, right? It could also take this shape like that. So both of these basically represent +x, and then we can have a large square like that, and that represents +x squared, right? So these shapes are going to be important when we are doing these questions, and we've gone through these in previous videos. Hopefully you've watched those videos before watching this one. If you haven't, highly recommend you do. If you're watching this on YouTube, you can go to the link in the description box and it'll take you to the site where everything is in order. Okay, so how do we do these? So let's start off with part A. We have the length equaling 3 and then the width equaling 2. So notice here we're just dealing with numbers. And so what you want to do is, if you're just dealing with numbers, then we're only going to be dealing with these kinds of squares. And the way that you do this, so a length of 3, what you would do is just draw the base of this square 3 times. So you'd have 1, 2, 3, like that, right? For the length. And then the width of 2, that's also a number. You would just draw 1, 2 for the width, like that. And so once you have the length drawn out and then the width drawn out, what happens is you want to create a rectangle. So what I usually do, I start off with the outer border. So I go to the topmost portion, draw a horizontal line, then I go to this most right portion and then draw a vertical line. And then what I do is whenever I see a space, right, on this portion, I draw a horizontal line from that space. Whenever I see a space in this portion in the length, I draw a vertical line from that, like that. And then what you want to do is you want to see what kind of shapes are formed over here. So notice, what do we end up with? Well, we end up with 6 of these small squares, like that. And so you just count these, 1, 2, 3, 4, 5, 6. And so the area in this case ends up equaling 6. Right? It's obvious to see because we're dealing with numbers here where length is 3 times 2, or length times width is 3 times 2, which gives us the area of 6. But when we get to these, it's not always going to be obvious what happens, right? So notice here for part B, the area, if we did it algebraically, would be the length times the width. So we'd have x plus 2 times x. But at this point in the course, we haven't really described how to work with something like this. We haven't went over the distributive property. That's going to be a future section. So there is a way to do this algebraically, but in this video, we are just focusing on how to do it visually like this. So how would we represent or model this area, right, where the length is x plus 2 and then the width is x, using algebraic tiles? Well, it's the same thing. It's just now in this case, notice the length is x plus 2. So it's not just a number 3, there is a number 2, but there's also a variable x over here. And if you remember, x is represented with a rectangle. And so the way we would represent this x in the length is we would just draw the base of this rectangle. We would just draw a longer base. So what would happen here, let me actually split these up. So what would happen here is we would draw a long base like that. So that represents the x. And then we would just draw 2 of these smaller bases. All right, so that's the length in this case. It's x plus, ends up being 1. That ends up being 1. So we got x plus 2 for the length. Now notice the width is just x. So what we would do is we would just draw a long line like this, but it would be vertically, right? Remember, this is the width over here. So that would end up being the width. So that would be x right there. And so what we do is exactly what we did up here. So we start with the topmost portion, draw a horizontal line, then go to the most right portion, draw a vertical line to get the borders of the rectangle we're working with. And then, as we did up here, what we do is we look for any spaces over here to draw a horizontal line. But notice in this case, there's no spaces, right? It's just this line over here. So there's actually not going to be any other horizontal lines that we draw. Now let's go to the base, the length here. Notice there's a space here, so we would draw a vertical line like that, and then over here we would draw a vertical line like that. And so notice, what are the shapes that it creates? Well, we have a large square, and then we have 2 rectangles. And so what the area ends up being, this over here, this square is x squared, and then we have 2 of these rectangles, which would be plus 2x. And that ends up being the answer. That ends up being the area for part B. And we're going to see in future videos when we start dealing with the distributive property, when we multiply these two, if we take x plus 2 times x, this is going to end up being this, right? So it's algebraically going to work out as well. And you can even come back to these videos after we've covered that section to confirm all of these calculations that we're going to do. But this is the process of how you do it visually with algebraic tiles, right? It's a little weird, but basically whenever you have an x, you want to represent that in the length or the width as a long line. And then any numbers, right? 3, 2, 2, 3, this 1, you want to represent with these smaller lengths like that. And then you just connect all of the lines, right? You draw the lines and then you see what shapes you end up with in that rectangle. And then from those shapes, you can get an expression for the area. So now moving on to part C, we have a length of x plus 3 and then a width of x plus 1. So same thing, the length, x plus 3. So notice we have 1x over here, so we would have a long line to represent that. And then let's actually put it lower. Right, so that represents the x, and then we have plus 3. So there's going to be 3 of those smaller lines like that. Right, so x plus 3 for the length of the rectangle, and now the width is going to be x plus 1. So the 1x there, that's going to represent a long line like that, And then we have plus 1, so that's going to be a small line like that, right? So one more time, we got x, 1, 1, and 1. So that represents x plus 3 for the length. And then over here for the width, we got x plus 1 for x plus 1 for the width. And so now what we do is we fill out this rectangle. So let's start with the outer borders like that. Notice there's a space here, so we would draw a horizontal line from that space, and then notice that we have 3 spaces over here, so we would draw a vertical line, and then a vertical line like that. And then what you want to do is you want to fill out the shapes that are created with these mini borders here. So we have a shape there, that's a rectangle. We got this, we got this, 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 and then that, like that. Okay, so with this length and this width, what's the area going to be? Well, we just count these shapes. So notice that we have a large square over here. So that's going to be 1x squared. So we're going to have x squared like that. How many of these rectangles are there? Well, there's 1, 2, 3, 4. Okay, so that means that there's going to be 4 x's. And then how many small squares are there? We got 1, 2, 3. And so we would have plus 3 as the constant right there. Right, so x squared plus 1, 2, 3, 4x plus 1, 2, 3 for the constant, right? The small squares just represent a number. And then that there ends up being the area, right? So if we take this, if we take x plus 3, multiply it by x plus 1, this is what we're going to end up with. And again, we're going to show that algebraically in a future video, but this is how you do it visually. Okay, so that ends up being the area for the rectangle in part C. And now finally, the rectangle in part D, we have a length of 2x plus 1. So notice now, for the length, there's going to be 2 of these long lines, and we're going to have a plus 1. So we're going to have one of those short lines, right? 2x plus 1, and then notice the width is x plus 3. So we would have a long line for the x, then we have 1, 2, 3. Kind of running out of room here. You know what? I just want to be able to show this clearly, so let's redraw this. So we got 2x plus 1, then we got the x like that. 1, 2, 3, like that. Okay, so let's draw the rectangle. Okay, and now notice we have 1, 2, 3 spaces. So we've got to draw horizontal lines from those spaces. And then we have 2 spaces over here, so we would draw vertical lines for those, like that. And then what you want to do, fill in all the shapes. So notice this shape, this shape, this shape. You actually don't even have to fill in. So another way you could do it here, let me show you another way. So if you want, you could fill in and then look at them like that. But another way you could do this is just within each shape, put the expression that it represents. So notice we have a large square over here, so that would be x squared. We have another large square over here, that would be x squared. Notice we have a rectangle here, that's x, x, x. Another rectangle, another rectangle, another rectangle, another rectangle. And then over here, we have 1, 1, and 1 for the numbers, right? We have 3 small squares. So what ends up happening, what does the area end up equaling? Well, we have 2 x squareds, like that, right? So those go away. How many rectangles are there? 1, 2, 3, 4, 5, 6, 7. So we got 7 x's, and then we have 1, 2, 3 small squares, like that. And so that ends up being the area as well, All right, so that's another way to do it. You could put the actual expressions for each shape as well. All right, so if we took this length, multiplied it by this width, this is the area we're going to end up with. Again, as I mentioned a couple of times already in this video, we are going to do this algebraically in a future video when we cover the distributive property, and we do more algebra then. But this is a way to use tiles to get these areas visually.